Hey, welcome back for some math fun. This one is for Derek because we have a big quiz tomorrow. We're going to look at number 3, and let me see if this will work. There it is, number 6, 3 and 6. Okay, I'm going to try some fancy stuff this time, so bear with me, and I'll try and not make it too long. Number 3, a Ferris wheel with a diameter, let me do this. A Ferris wheel with a diameter of 220 feet takes 42 seconds to rotate once. That means one revolution, 42 seconds. We need the angular velocity in radians per second. Just change 42 seconds for a rotation into radians per second. Secondly, determine the linear velocity. So that's our formula. Let's do the first one. Let's see. So part A, we need to take one revolution in 42 seconds and convert it into radians per second. So to convert a revolution, you multiply by 2 pi radians over 1 revolution. And magically, revolutions cancel. And look what you have, 2 pi radians per second. That's what I wanted. I needed radians per second. So you go through and you calculate that in your calculator. Wrong. Okay. You do 2 times pi, divide by 42. That will give us, let me see, hold on, rounded to the hundredths, 0.15 radians per second. And if you look on the back, there's an answer key, and that's what you get. Now for part B. Part B, determine the linear velocity. Let me see if I can squeeze this on. Let me see. Looking at part B, linear velocity is equal to the circumference times the angular velocity. Remember the angular velocity we have here. One revolution, 42 seconds. And we have a circumference, but it's the diameter that's 220 feet. So to put this into the formula, 2 pi is times 110 feet for the radius. And remember, circumference is always with 1 revolution. It takes 1 revolution to go around the circle, times the angular velocity, which was what we started with, 1 revolution in 42 seconds. And let's go back to the problem. Let's see. Back to the problem. It says determine the linear velocity in feet per second. Well, magically, let me go back to our formula. In our formula, revolution cancels, and I'll have feet per second. So what I need to calculate here in my calculator, do 2 times pi times 110. Take that answer, divide it by 42. That will give me, I have to look. That gives me 16.46, and look back at our labels, feet per second, and that's what it asked for. Let me write it and we'll go check. Feet per second. Go back down. Yeah, linear velocity in feet per second. So done. Let's look at number 6. Let me see what I can find here. Number 6, a flywheel mounted on an engine, this is one we're looking at, has a radius of 6 inches. So we got a flywheel mounted on a crankshaft. That's on the outside rim. If the engine is running at 2,800 RPMs, that's revolutions per minute, what's the linear velocity of a point on the outer edge of the flywheel? Now feet per second, so we have to be careful about that part, and this is a typical problem. Let me focus in so we have room to write. And you have your formula that we start with. The linear velocity is equal to the circumference times the angular velocity. We can figure out the circumference because we have a radius, let me move it over, a radius of 6 inches. So if I go back to my formula and hope I can write, there we go. The circumference with a radius of 6 is 2 pi r, which is 6, times inches, I believe. Let me look at my paper copy. Yes. And circumference is always out of 1 revolution, times the angular velocity. The angular velocity said it was, let me go back, this is fun times. Here we are, 2,800 RPM. So, times 2,800 revolutions per minute. Nicely, revolution cancels revolution. But this is leaving me with inches per minute. And my question says that it has to be feet per second. So if it says, let me show you, make feet per second, there it is, feet per second. I have to convert both inches, inches to feet, minutes to seconds. My conversions then, I need to multiply first. Let's get inches. If I have an inch in the numerator, I need an inch in the denominator. But it's 12 inches in a foot, and I need to get feet. So I put 12 inches down here, and you get 1 foot. And inch cancels, and I have foot. Then I also need a conversion for my minutes. So if I have minutes down here, my conversion, I need minutes up top, and I have to go to seconds. So that's 1 minute gives me 60 seconds. And conveniently, minute, oops, I went red. Minute cancels minute, and I have foot per second. So in my calculator, what I need to do is put in 2 times pi times 6 times 2,800, and then divide it by, in parentheses, 12 times 60. You need to make sure you put all of this in parentheses, hit the divide sign, put that all in parentheses. And that is feet per second. And that comes out, if you put it in right, make sure you try this and do it right, 146.61 feet per second. And let me move over, I can't write it all. Feet per second. Yay, done.